As we know that this 8279, which is also known as the programmable keyboard display controller, it is usually used to interface the keyboard and the display devices with the CPU or the microprocessor. Now, when it is interfaced, there are various modes in which it can do its operations, and these modes are like input modes and the output modes. So, if we say about the modes of 8279, then we have input modes and output modes. These input modes are also known as the keyboard modes, and output modes are also known as the display modes. So in input modes, we interface the keyboard with the central processing unit, and in the output mode, we interface the display devices with the CPU. Okay. Now these input modes, they can be of various types like scan keyboard mode or scan sensor mode, strobed input mode, and output modes can also be of different types. So these modes, they have the command words which are written into the control registers, and these control registers then define that which mode the 8279 it is going to work. So the first command word, it is for the keyboard display mode set. Means this command word, it is setting that either the 8279 it is going to work in the input mode or it is going to work in the output mode. So first command word we will study is for the keyboard display mode set. So the different modes which come under the category of the keyboard modes and the display modes, they can be set using this command word. Okay. So let us study the command word. This command word, it consists of 8 bits from D7 to D0, and all these command words, they are written or read, and their status can be read when the value of the line A0 is 1 and the CS line it is equal to 0. Because when A0 is 1, then this chip 8279 will be addressed by the microprocessor, and when this CS bar, which is the chip select signal, it is 0 because it is having a bar over it, so it's an active low signal. So when its value is 0, then only this 8279 will be connected with the CPU or the processor. So for writing the command words into 8279 or to read the command words, these two lines has to be A0 has to be 1 and CS bar has to be 0. Now again let's come to the command word for the keyboard and the display mode set. Now the command word, it consists of the 8 bits starting from D7 to D0. D7, it is the most significant bit, and D0, it is the least significant bit. Now here we have also written the status of the A0 line. I have said that A0 has to be 1 and CS bar has to be 0. So here I am writing the status of A0 as 1 and CS bar signal, it has to be 0. Now in this command word for the keyboard and the display mode set, this D7, D6 and D5 bits, they are kept at the logic 0. This logic, it is fixed for the keyboard display mode set. This has to be 0, 0, 0. Okay. Then we have D4 and D3 bits, which are, I have written here DD. That means these two bits decides the display modes, and K means they decide the keyboard modes. So these two bits are for the display modes, and these 3 bits are for the keyboard mode. Okay, so they are going to decide that which of the display modes will work, and these 3 bits will decide that which of the keyboard modes will work. So let us study the combination of these 2 bits. First we will study the display modes. So we have D and D. They can have values like 0, 0, 0, 1, 1, 0 and 1, 1. Now when their value is 0, 0, then we have the mode as so when these value is 0, 0, then we have the mode as 8-bit character left entry. Because in the display modes, we have 2 types of mode. One is the display scan and one is the display entry. So this mode, it is deciding that the display data, how it is going to enter on the display screen. Okay, so display entry mode, we have 2 types. One is the left entry and one is the right entry. So here the display modes, they are deciding that the data, the display data, how it is going to enter, whether it will have a left entry or it will have a right entry. Now the data, it can be a 8 16-bit character or 16 8-bit characters can be there. So 0, 0 means 8 8-bit characters left entry will be there. Then 0, 1 means 16 8-bit character left entry is there. Then for 16 8-bit character right entry, we have 1, 0 and 1, 1 is for 16 8-bit character right entry. So these are the values of the 2 bits D4 and D3 for the display modes, display scan and display entry. Okay. Now let us come to the keyboard modes, the bits D2, D1 and D0. So here we have K, K and K. Now we have different combinations for these 3 bits. So these 3 bits can take 8 combinations. Now when the value is 0, 0, 0, first I am writing all the modes, then I will explain you that what these modes describe. When it is 0, 0, 0, then we have encoded. So when the value is 000, we have the mode encoded scan and 2 key lockout. In the keyboard modes, we have the 3 modes. One is the scan keyboard. Then we have scanned sensor matrix. And the third is a strobed input. So these are the 3 modes in the keyboard mode. So we have first, we have the scan keyboard mode. It is also of 2 types. One is the 2 key lockout and the other is N key rollover. Now every mode of the keyboard modes in the keyboard mode, it will have 2 types. One is the encoded scan and second is the decoded scan. In the encoded scan, we have the size of the matrix of this keyboard as 8 cross 8. In encoded, we will have the size 8 cross 8. Whereas in the decoded, we will have the size as 8 cross 4. Okay. So the size is different of the keyboard in these 2 modes. So every mode of the keyboard mode, it is divided into 2 types, encoded scan and decoded scan. So we will have encoded scan 2 key lockout, decoded scan 2 key lockout. Then we will have encoded scan N key rollover, then decode scan N key rollover. Now for sensor matrix, we will have encoded scan and decoded scan, and then for strobed input, we will have encoded scan and decoded scan. So we have the 8 combinations 000, 001 till 11. Sorry, this is 1. So 111, we will have the 8 combinations, and these combinations will decide that which of the keyboard mode will be active. So the first we have studied about the keyboard display mode set. This is the command word. So in this command word, just remember the logic of all the 8 bits. D7, D6, D5, they have to be always at 0. D4 and D3, they will decide the display modes, and D2, D1, D0, they will decide the keyboard mode. And A0, it is always at logic 1, and CS bar, it is always at logic 0. So this was the command word for the first keyboard display mode set. Now let us come to the second command word, which is for the programmable clock mode. Now let us see the command word and what this mode decide. Whenever because every device, every IC, it will have a clock frequency, because this clock frequency is necessary to synchronize the timing and the control operations of the device or the IC. Okay, so clock frequency or clock crystal is necessary for a device to work. Now this clock frequency, it is obtained by dividing the input frequency. Okay, so in this programmable clock mode, the input frequency, it is divided. Okay, so we can say here that so whenever a frequency, an external frequency is provided to the device, then the device, it is going to divide it by some constant value, so that it will obtain the input clock frequency. So here it is written that the clock for the operation of 8279, it is obtained by dividing the external clock input signal by a programmable constant called prescaler. So this external clock input, it is provided by the crystal, so that frequency will be divided so that the input clock frequency is generated. Now, by which this is to be divided? This external clock frequency, it is divided by a programmable constant which is known as the prescaler, and this programmable constant, it is provided in the command word of the programmable clock mode. So let us see the command word for this mode. Again, the command word, it is going to have the 8 bits. Now, along with the 8 bits, I have written the A0 line also. So, A0 line, it is always at logic 1. Now, for this programmable clock mode, this D7, D6 and D5 bits, they have to be 0, 0, 1. Earlier, it was in the keyboard display modes. These were 0, 0, 0. Now, in programmable clock mode, they are 0, 0, 1. Okay, so these are always kept at logic 001 so that the 8279, it will work in the programmable clock mode. Then we have 8 D4, D3, D2 and D1, D0. We have P, P, P and P. We have the 5 bits here starting from D4 to D0, which are the bits of the programmable constant, which is also known as the prescaler. So now these D4 to D0 bits, these are the 5 bits of the count which is loaded into this command word, and this count, it is the value of this prescaler, that is the programmable constant by which this external clock input signal has to be divided so as to obtain the clock input signal. Okay, so here this P, 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 these are the 5-bit binary constant. Now the input frequency, it is divided by this decimal constant, which is ranging from 2 to 31. So the value of these 5 bits, it can be 2 to 31, and this value, this used the input frequency, it is divided by this value so as to obtain the input frequency. Okay, so the external, we can say, external clock input, it is divided by the prescaler, which is the 5-bit binary constant, so as to obtain the input clock frequency. Okay, so this was the programmable clock mode. It was the command word for this. Here D7, D6, D5, they are at constant logic 001. These 5 bits are the binary constant, and A0, it has to be always 1. Now next, come to the third mode, which is the read FIFO sensor RAM. Whenever we want to read the status of the key which is pressed on the keyboard, because every time a key is pressed, the key code related to the key will be stored in the FIFO RAM. Okay, and also if any sensor is interfaced with the 8279, then also the information will be stored in the sensor RAM. So whenever we want to read the FIFO or either the sensor RAM, we can use this command word. Again, it will have the 8 bits D7 to D0. Now D7, D6 and D5, they are at the logic 0, 1, 0. Okay. Earlier it was 0, 0, 0, then 0, 0, 1, and then it has become 0, 1, 0. So you can see that a pattern has been followed here. Okay, so these are at constant logic for this read FIFO sensor RAM mode. Then we have D4, which is AI, D3 it is X, D2, D1, D0 they are A and A0 it is always at the constant logic 1. Now this AI, it stands for the auto increment flag. Then X, it is the don't care bits. Don't care bits means these bits can have either 0 value or 1 value. It will not affect the command word. That is why they are known as the don't care bits. So D2, D1, D0, they are AAA, which are the address pointer to the 8-bit FIFO RAM. Okay. Now this FIFO RAM, it has some address because whenever we want to read some data from a memory, so we want the address of the memory location. Now the address of that memory location, it is here because this FIFO, it is an 8-bit FIFO RAM. So the address has to be of the 3 digits. Okay, that means 000, 001, 010. So we can have 8 combinations of 0 and 1 here. So we can say that the AAA, it is the address pointer to the 8-bit FIFO RAM. So whenever we want to read the data from the FIFO or the sensor RAM, we are going to provide the address of the memory location and this D2, D1 and D0. And this auto increment flag means first memory location we have read, then second memory location we want to read. So auto increment, this flag will be automatically incremented so that the pointer will jump to the next memory location and then second memory location will be read. Now let's take an example. Suppose this we have 000, 001, 010. These are the 8 memory locations. Now we have given the address of the first memory location here as 000 and we have set this bit a auto increment as 1. So first this memory location will be read, then it will check that this auto increment flag it is 1, so automatically this will increment to the next memory location, then this will be read, then 010, then 011. So in this way all the 8 bits or the 8 memory location of this FIFO RAM, they will be read by the 8279. So this is the function of these D4, D2, D1 and D0 bits. Okay. So I can write here that this command word is used to set It is used to set up 8279 for reading FIFO sensor RAM. Okay. AAA, it is pointing as it is a pointer register which is pointing towards the memory locations of the FIFO sensor RAM. Okay. And AI, it is automatically incrementing the addresses. So this was the third mode, the read FIFO sensor RAM. Then we have the next mode as the read display RAM. Now The RAM which is associated with the input devices, that is the keyboard, it was the FIFO RAM or the sensor RAM. Okay. Now when display devices are interfaced with the CPU, then for the display devices we have the display RAM. So this display RAM, it can be either read or it can be written, but the RAM which is associated with the input devices, it can only be read, it cannot be written. Okay, because input is always provided to the 8279 never provides the input. So this FIFO and sensor RAM, they are always read, no written operation is associated with it. And display RAM, it has both the read and the write options. Okay, so first we will study the read display RAM. So the command word for this is, again we have the 8 bits. So here we have the value of D7, D6, D5. Earlier we were having 0, 0, 0, 0, 0, 1, 0, 1, 0. So this time we will have 0, 1, 1. Okay. So this is at the constant logic of 0, 1, 1 for the read display RAM mode. Then we have D4. Again we have auto increment here. This is always at logic 1, A0. Now we have the 4 bits here, because the display RAM, it is of 16 byte. Okay, so it will have an address which is of 4 bits. Okay, so because FIFO RAM, it was of 8 byte and display RAM, it is of 16 byte. So address associated with FIFO RAM will have 3 bits, and the address associated with display RAM will have 4 bits. So this is the 4 bits memory address, and it is again the auto increment flag. So again here I'm writing here that AI, it is the auto increment flag, which is automatically incrementing the addresses. And AAA, it is the address pointer to 16-bit display RAM. So for auto incrementing the flag or the addresses, this AI bit, it has to be 1. So this D4 is equal to 1, then the addresses will be automatically incremented. So this mode, this read display mode, it is preparing the 8279 to read the data from the display RAM. Okay, that is, it is preparing the 8279 for the read operations. And here we have the auto increment flag, and the AAA are the addresses. Next we have the write display RAM mode. Now again we will have the command word for it, and this mode, it is preparing the 8279 for the write operation, means to write the data on the display RAM. So it will be 100 for the write display RAM option. Okay, these are at constant value. Then D4, it is again for AI, and these are for the AAA, the addresses, and A0, it is 1. So only the difference between the write display RAM and the read display RAM, it is of the value of this D7, D6 and D5. Otherwise the rest of the command word, it is same. So in read display RAM, we will have the value 011, and in write display RAM, we will have the value 100. And this will write the data on the display RAM, and again the addresses will be incremented. This display RAM, it is of 16 bit, so the addresses will have 4 bits. Okay, like 0000, then 0001, till we will have the last address okay, the 15th memory location, starting from A0 to A15. So these are the different modes of the 8279 and the command words for the modes. First, we studied about the keyboard display mode set, which is deciding that the command word will decide that which of the modes, either keyboard mode or the display mode, will work. Then we have the programmable clock, which is deciding that the input frequency, how this input frequency is obtained, by what factor the external clock frequency has to be divided so as to obtain the input clock. Then we have the read FIFO sensor RAM, then read display RAM and write display RAM. So these were all the command words of 8279 programmable keyboard display controller. So I hope that this topic is clear to you. Thank you.